All right, here's a proof that actually showed up in 4-6, and if you read the chapter, but we just didn't get a chance to prove it in the lesson, so didn't have enough time to squeeze it in the 30 minutes. But here we're given that AB is congruent to AC, so we have an isosceles triangle here, right? Okay, let me draw this, or let me write in the given. So AB is congruent to AC. Right, and then we're also given that AD bisects angle BAC. Okay. All right, so in other words, we have an isosceles triangle here, ABC, and we have a line that bisects the vertex angle, right? So this angle A is the vertex angle. So we have a line that bisects it, and we're trying to prove that that BD is congruent to CD, so that not only does AD bisect the angle A, but also bisects side BC. But not only is it a bisector, but it's also perpendicular, right? So it's a perpendicular bisector. Okay, so that's theorem 4-5 actually in the book, that says that if you have a line that bisects the vertex angle of an isosceles triangle, then it must be a perpendicular bisector with the base. Okay. All right, so let's see. And this is one of those that it might help to write at least the large triangles separately, just so you can kind of see the pieces. So we have this is congruent to this, right? And so if that's true, if those two sides are congruent, that must mean the base angles are congruent, right? Angle B must be congruent to angle C. So we can say that angle B is congruent to angle C. Okay? And that's because of isosceles triangle theorem. All right? Next, we can say, okay, well, if we have something that bisects an angle, that means it creates two congruent angles, right? So this angle must be congruent with this angle. So angle 1 is congruent with angle 2, right, by definition of bisector. Angle bisector. All right, and let me put two arcs there so I don't think that they're congruent with these ones here. All right, so now we have angle side angle, right? So we can say that triangle ABD is congruent to triangle ACD, right? And that'll open up the door for CPCTC, which helps us to do that, and then we can kind of down the road a little bit get that one. Okay, so we know triangle ABD is congruent with triangle ACD, right? Those are the corresponding. A corresponds with A, B corresponds with C, and D corresponds with D, and that's by ASA, angle side angle theorem. And so now that we have that, we can say, okay, well, BD must be congruent with CD, right? So we can prove that part of it. Okay, and that's by CPCTC. And while we're on CPCTC, we want to also prove that we can say that angle 3 and angle 4 are congruent, right? Because if we can say that these are congruent and they form a linear pair, then that must mean that they're right angles, right? All right, so then we can say that angle 3 and angle 4 are supplementary by the linear pair postulate. Okay, and so if two angles are congruent and supplementary, then they must be right angles, right? And that's, let's see, what theorem is that? Yeah, that's theorem 2-5 in the book, but you have two angles are congruent and supplementary, they must be right angles. So angle 3 and angle 4 are right angles, because supplementary and congruent means right angles. Okay. All right. And finally, we can say that angle 3, or we can, let's say it this way, we can say that AD is perpendicular to BC, right? Because they form right angles. So AD is perpendicular to BC, and that's by definition of perpendicular, right? Because if perpendicular lines form right angles. All right, so there we proved it. We proved that that BD is congruent with CD, and we proved that AD is perpendicular to BC. So we proved that AD, since it bisects the vertex angle of an isosceles triangle, that must mean it's also the perpendicular bisector of the base of that isosceles triangle.